Optic is transforming the way we see the eye, from advanced imaging to real-world application in clinics. Today, I'm excited to be joined by Dr. Alfonso Jimenez Vera, a postdoc scholar at Ocular. His works focus on ocular imaging and clinical translation, and he has published multiple papers pushing this field forward. And I can't wait to dive into his insight on where this technology is headed.
That's simple. I'm a Spanish postdoctoral scholar that works at the Cool Lab, that is the scientific lab of Professor David Juan, who is one of the co-inventors of optical coherence tomography. And I'm really happy to help my friend Naishin in this project and see how it works.
Would you talk about the market of the ocular imaging we're developing?
Since that we are talking about the market and who have the money in this case. And I'm going to put an example. For example, you know that now we are living a boom of AI, okay? And there are multiple models that are used for retinal applications. And my question is, why for retinal applications and not for cornea applications? And then you start to think, or you start to look for AI models in internet, and you don't find anyone in cornea. And there is a moment that you start to think and say, okay, who is developing the AI models? Countries who have resources, economical resources.
Yeah.
Now, what are the main pathologies that the developed countries have? Are in cornea or in retina?
In retina.
So, what I'm going to invest, what I'm going to develop? AI models for retina imaging. OCT is the same. OCT is mainly used for retina because apart that you can image the retina and all the diseases, most of the developed countries have retinal issues like macular degeneration, glaucoma, another one, it doesn't come to my mind, another example, diabetic retinopathy. But when you study the statistics, the main blind reason is cataracts from the anterior segment.
Yeah.
But cataracts can be easily diagnosed, and it's a problem that mainly non-developed countries have. So, like you go, for example, to Ecuador. In the last ARBO meeting, I met an ophthalmologist from Ecuador, and one of the main problems that they found is that people who live next to the jungle didn't go so often to the ophthalmologist, so they didn't diagnose the cataract. So when they arrive to the hospital, they have the problem that the cataract is very well developed. Here in whatever developed country, you don't have that problem. So this is actually the main reason. The other reason, especially for OCT, is that data limitation, because you need to acquire a very huge volume. OCT provides you a 3D image of the retina of the anterior segment. But the volume from the anterior segment is huge in comparison with the retinal one. Do you think that we have the technology to do the measurements in a few seconds, send to the computer, and storage the data files?
Could be hard.
It could be really hard. And then there is another thing. Most of the ophthalmologists are really comfortable using the slit lamp. Slit lamp is a device that what it does is to project different illumination techniques on the cornea, and you can with a microscope, a binocular microscope, you can image the cornea, but it's so flexible that you can do multiple tasks immediately. OCT cannot do that. So that's why OCT focus on retina,